So till now we had looked into some of the inequalities where modulus was not involved. Now here we have a set of questions. You can look, we have two set of questions where modulus is involved, and this question number 2 that we have, this has already appeared in the exam JEE 2002. So such type of questions are really important, and we need to understand how do we proceed when we have questions related to modulus in equations. Now, by now I am sure you understand what the meaning of modulus is. The simple understanding of modulus starts with, if I say modulus of 2 is simply 2, this is known as modulus, and this is also known as absolute value. Now if a number is positive and we take its modulus, it remains the same. But if we have a number, let us say -2, its modulus gives us the answer equal to 2. That is, the absolute value of -2 is equal to 2. So this is basically the understanding of a modulus. So before we get into solving these questions, we need to understand the modulus function. So as you understand, it is basically whatever we take, it neglects the negative sign, it neglects the sign and gives us the value. So here a modulus function, if we have a function fx is equal to mod of x, it is defined in the following manner. Now if you are new to this concept of functions, so basically it is something where it is represented as f of something, and on the right hand side we have what this function does. So f here stands for function. It takes the input as x. We feed in the input in the form of x, that is what we call as an output, and what it gives us, so basically it gives us mod of x in this case, because we have taken the function f of x as mod of x. So basically on the right hand side, this is the output. If you are new to this concept of functions, let me give you a small understanding of this. Now suppose we take the value of x as 1, x as 0, or -1, or 2, or for that matter -2, or for that matter let us take it as 10, and so on, any number. Now if we give this input to our function, if let us say here is our f, if here is our x value, and let me write f of x here. So here if we have the value of x, let me write down the value of f of x in the next column adjacent to the value of x. Let me also separate these two values by a line so that there is no confusion. Now if we take the value of x as minus of 10, we can write f of minus of 10 is equal to modulus of -10, and from the definition that we have understood what a modulus does, it just gives us the absolute value by ignoring the sign, and hence the answer we have is 10. And similarly, when x is equal to -2, the answer turns out to be 2. When x is 1, it is the same. 0, again the same. -1, it gives us an output 1, and when x is equal to 2, it is equal to 2. So this is how a modulus function operates. So x is basically the input that we give, and here f stands for a function, and this is how our function is defined. Now we will discuss in detail about functions and various different kinds of functions in the chapter relations and functions. For now, it is enough to understand how this function is written, and it takes an input and gives us an output, and we are only considering about the modulus function here because we need to study the inequality related to modulus. Now here there are two things. First, let us understand how we can define this function properly so that we can apply it in question, and the second thing is the graph of it. So the first thing is definition. So let me write the definition of f of x, which is given as modulus. So we know if x is a positive number, let us say if x is a positive number, the output remains the same when x is either greater than equal to 0. So basically what we have done is, if you take a number line, let us take a number line here, there is a value 0 here. Now all the values which are on the right hand side of 0, they are not affected by this function. If we take a value 1, the answer is 1. If we take the value 2, the answer is 2. If we take the value, let us say 1001, the answer is again 1001. If we take a value of x as 4 upon 7, the answer is again going to be 4 upon 7. So fx returns the same input if x is greater than 0. So this is how the first part of it is defined. So we have dealt with all the values of x which lie on the positive side of 0 or on the positive x-axis or on the positive number line. But still, this definition is not complete because we have not defined what happens if the value of x is negative. Now, you understand, if we take a value minus 2, it gives us an answer 2. If we take an input minus 10, it will give us an answer 10. If we take the input as minus of 413, let us say, any random negative number, it will give us an output 413. Or for that matter, if we take the value of x as minus 10 upon 13, it will give us an answer 10 upon 13. So what we understand is, if x is negative, if x is less than 0, it gives us the negative of that number, or that is to say, the positive value ignoring the negative sign. So we define for the negative x as fx is equal to minus of x. So that is how the definition of modulus function stands for all values of x. So basically this function is defined in two parts. Part 1, where x is either 0 or positive, greater than 0, and the second part where x is less than 0. So this is about the definition of the function, which is mod of x, or we also call as absolute value. Now we will be using this particular definition in order to solve questions when we come across modulus sign. We'll have to figure out at what point or the value becomes positive and at what value the modulus or the terms inside the modulus sign starts to become negative. So let us see how do we do that when we start solving questions. So this is the definition. Another thing that I want to discuss here is the graph of the function. Now we have our function f of x, and what we do is we plot the value of f of x, that is the output that we have, on the y-axis. So input is basically x and output is y. So this is how we are going to plot it. So for this, you understand that we have to take a graph, 2D graph. Let this be the x-axis. So on this line, we'll be taking the values of x, and on this line which is perpendicular to x-axis, we have a y-axis where we will be taking down the output of this function. So by now we have understood that fx is equal to x for x greater than equal to 0 and minus x for x less than 0. So let me number these two x-axis and y-axis. So let us take here as 1, this is our 0, 2, 3, minus 1, -2, -3, -4 and so on. Let me mark here 1, 2, 3, 4, 5 and so on. And similarly on the negative y-axis we need to have the following marks. So this is how our graph looks like. Now let me draw a small table here where we are going to record the values of x and y, that is the inputs and the outputs. So let us say the first input that we take is x equal to 0. We get the value of y as 1, as 0. We take the value of x as 1. We get the value of y as again 1. We take the value of x as -1. We get the value of y as 1. We take the value of x as 2. Y is 2 again. If we take x as -2, y is 2. So these are some of the input and the corresponding values that we obtain by using the modulus function. Now we also have these inputs and outputs. These we can also use. So let us see what do we have. So first point that we have here is 0, 0, which is nothing but the origin. So let me mark this point. Second is 1, 1, which point lies here. I have drawn these two dotted lines for the sake of understanding. Let us take -1 and 1. So -1 for the value of x is on the x-axis and 1 is here corresponding. So just this point, if you look at here in the diagram, is nothing but the mirror image of the point 1, 1. And similarly, let me take point 2, which will lie here, and similarly corresponding value for x equal to -2 is here. Let me also take some more values. If we take x equal to 3, we have a point here. If we take x equal to -3, corresponding value of y is this. So this is how we have marked the points which satisfy this function fx is equal to modulus of x. Now we see that if we move 1 unit on the right, we have to move 1 unit towards the positive y-axis as well. Now again, if we move 1 unit on the right towards the x-axis, towards the positive right, we have to again move 1 unit upward on the x-axis, and here also it is the same thing. So basically the rate at which the function or these values are increasing is the same, which means this line, if we are considering only the right hand side of this graph, is going to be a straight line passing through all these points. So this is how the right side of this function would look like. Now similarly, if we try to join these points on the left, we will obtain a line of this nature, and this is what the graph of modulus function looks like. Now also, if you have an intuitive idea of plotting a graph, you can also see that since we have taken fx is equal to y, you can write this function as y is equal to x for x greater than equal to 0, which means this is a straight line which is certainly going to pass through the origin, and it has slope equal to 1. So slope equal to 1 is basically the coefficient of x, and we know that slope is also defined as tan theta equal to 1, and that gives us theta equal to 45 degree. So basically this is such a line which is inclined at an angle of 45 degree with the x-axis. So this is how the positive side looks like. Now you should note that this part y is equal to x is valid only when x is greater than equal to 0. So you do not have to consider this function or this equation for values less than x. Now let us consider the other part, that is when x is less than 0. Now in this case we can write y is equal to minus x. Now this function or this equation for values less than x. Now let us consider the other part, that is when x is less than 0. Now in this case we can write y is equal to minus x. Now so 2x minus 3 is less than 0. So this negative number, absolute value, if we use the function, it will bring a minus sign. If we try to eliminate this modulus sign, it brings in a minus sign here. So we need to write minus of 2x minus 3 is less than x minus 1. If we simplify this further, we have minus of 2x plus 3 is less than x minus 1. Let us try to simplify this. So we take minus 2x on the right hand side and we bring 1 on the left. So we have 4 is less than 3x, or we can write x is greater than 4 upon 3. So now we again have two cases and we have the solution set for both of them. So let us now try to plot them on number line. So let us say here is the number line. Let us mark the important points, 3 by 2. Then we need to mark the point 2. We need to mark the point 4 upon 3. So 4 upon 3 is certainly less than 3 by 2 because the value of 3 by 2 is 1.5 and 4 upon 3 is 1.33. So let me mark 4 by 3 here. So in the first case, the solution is x should be greater than equal to 3 by 2. That is, here we need to have a solid circle and it is less than 2. So at 2 we have a hollow circle and all the values of x lying in between are also a solution. Let us look at case 2. Here x should be less than 3 by 2. So let me mark a hollow circle here, and x should be greater than 4 by 3. So let me similarly mark a hollow circle here just above 4 by 3, and all the values lying in between are the solution set. So clearly we can find that all the values greater than 4 by 3, including 3 by 2 and up till 2, excluding 2, are a solution set. Why we have included 3 by 2? Because 3 by 2 lies in case 1 and it satisfies both the conditions. 3 by 2 is also less than 2 and 3 by 2 is greater than equal to 2. So if we take this whole scenario, we get the solution of x as 4 upon 3 to 2. So that is how we solve questions related to inequalities, related to modulus. And let us also now try to solve questions where we have more than one modulus, and we'll then look at one another question where modulus is there in a quadratic equation. The second question that we had was the following: modulus of x minus 1 is greater than equal to modulus of x minus 3. Now in this case, if you look at the question, here there is 2 modulus sign. So let us see how do we solve this. Now if you understand that here when we have a modulus for x minus 1, the definition for modulus of x minus 1 will change at the point where x minus 1 becomes 0. That is to say, at the point x equal to 1. So at x equal to 1, on the left and the right, the definition of this function, that is modulus of x minus 1, will change. Similarly, if we consider the function modulus of x minus 3, it is going to change its nature at the point x equal to 3. For a clear understanding, let us consider these two functions separately. Let us first consider f of x equal to mod of x minus 1, and let us try to understand this function before getting into this inequality. So in order to understand this, we have a x-axis and we have a y-axis. X, y. So here, definitely at x equal to 1, this function is going to give us an output equal to 0. So let me mark the points 1, 2, 3, 4 and so on, minus 1, minus 2, minus 3 and so on. On the y-axis, we have 1, 2, 3 and so on the positive side. On the negative side, we have minus 1, minus 2, minus 3 and so on. So at x equal to 1, it is going to give us an output equal to 0. So here is the first point that we have. When we put x equal to 0, it will give us modulus of 0 minus 1, that is minus 1 modulus, and that is equal to 1. When we put x equal to 2, that is, we want to find the value for this particular value, x equal to 2, 2 minus 1 is 1, taking the modulus gives us the same value, here 1. By the dotted line, I want to show you how we are trying to plot these points. When we take x equal to 3, we get the value of fx as 2 here, and when we take minus 1, it becomes minus 1 is minus 2, modulus is 2 again. Similarly, at 4, we have the value equal to 3, and at x equal to minus 2, we get the value again as 3. Now let us try to plot this function. So observe carefully. The function that we get is as follows. And if you want to write the definition of function in these two parts, we can write f of x is equal to x minus 1 when x is greater than equal to 1, and minus of x minus 1 when x minus 1 is less than 0. So this is how the modulus of x minus 1 looks like. Now this point, now look at this point carefully. This is the point where the nature of the function is changing. Why do we call it the nature is changing? Because if you take all the left side of this on this x-axis, the slope of this line is negative. And if you take all the points on the right hand side, you see that the slope on the right hand side is positive. And that is how we say, and that is why we say the nature of graph is changing at the point x equal to 1. And such a point is known as critical point. Now that we have understood the graph of modulus x minus 1 and we have also written down the function properly, let us now try to analyze the function modulus of x minus 3. So here the question is, how will the graph of function modulus x minus 3 would look like? Now by repeating the same method, we would find that the graph of this modulus remains exactly the same except for the for the point that here the critical point is not 1 but it is 2. So let me do the markings first on the x and y axis. 1, 2, 3, 4, minus 1, minus 2, minus 3. Here is our origin. 1, 2, 3, 4 and so on. Minus 1, minus 2, minus 3, minus 4 and so on. Now by repeating the same method, we get the following points: 3, 0, 4, 1, 2, 1, 1, 2, 5, 2, 0, 3 and so on. And if we join all these points, the graph is as follows. So this is how the graph of modulus x minus 3 looks like. And here the critical point is at x equal to 3. So basically, if we map these two graphs together, or not map, but if we plot these two functions on the same graph paper, so here is the graph of modulus x minus 3. Modulus x minus 1 would look like the following. Very interesting, isn't it? Now just see how beautiful the curves look like. Now in order to solve this mathematically, we need to have the following partitions on the x-axis. Now look at all the points from minus infinity to 1. Carefully note this range, minus infinity to 1. Now here just notice the nature of the function. For modulus x minus 1, it is having a same nature, it is decreasing linearly. And if we consider the modulus x minus 3 function, for all values from minus infinity to 1, it is decreasing linearly as well. So till the point x equal to 1, both the functions are behaving in a same manner. I mean, the nature of the function is not changing from minus infinity to 1. Let us now look at the range in between x equal to 1 and x equal to 3. Now here, the nature of the function modulus x equal to 1 is increasing and modulus x minus 3 is decreasing. But in between 1 and 3, it is not changing. It is the same for all. Now, if we consider the right hand side of the number line after 3, here also again, the nature of these functions are not changing. So basically what we have done is, we have found the critical points for all the modulus functions involved in the inequality, and we have marked them on the number line. And if we want to solve this question methodically using the help of equations, inequations and expressions mathematically, so what we need to do is, we need to divide this question in 3 cases. Case 1, when x belongs to minus infinity to 1. Case 2, when x belongs to 1 closed, open 3. And case 3, when x belongs to 3 and higher values of x. So I hope these three different cases, why we have come up with these 3 different cases, is now very clear to you. So let us now try to understand this inequation in these 3 cases. Now, when x is in between minus infinity to 1, both of them are negative, and hence we have if we want to solve this, we need to write minus sign in front of x minus 1, and this is greater than equal to minus of x minus 3. If we multiply minus 1 in this inequation, we know that the inequality will reverse. So what we will have is the following, and that is x minus 1 is less than equal to x minus 3. And if we look at this equation, we find that x cancels out, and hence there is no solution in this case. So x cancels out, and hence we cannot do anything. It does not give us a valid solution. Let us look at the interval when x belongs to 1, 3. Now here, when x is greater than 1, the modulus of x minus 1 remains x minus 1. And then let us put the greater than equal to sign. But for modulus of x minus 3, we need to have minus of x minus 3. So let us now simplify this. So we have x minus 1 is greater than equal to minus x plus 3, which gives us 2x is greater than equal to 4, or x should be greater than equal to 2. So 2 is the point here, and corresponding to this, here is the value that we are looking for. So now we have a solution. Now x in between 1 and 3 should be greater than equal to 2, and hence we can write x should belong to closed 2, open 1. So this is what do we have from case 2. So now in the third case, we have x minus 1 modulus simply becomes x minus 1, and then we have to have a greater than equal to sign, and then we have x minus 3. Now x and x cancels, and what we have is minus 1 is greater than equal to minus 3, which is true in all cases. So no matter what value of x you take, it is going to be true, and hence all the values in this range are going to satisfy the inequality that we have. Now in the case 1, when x cancelled out, why we did not have any solution is because here we finally got minus 1 is less than equal to minus 3, which is incorrect, and hence there is no solution in this portion. And from here we can write x belongs to 3 to infinity. And if we club up all these three cases, we have the solution x belongs to 2 to infinity. So that is how we solve questions related to modulus functions and their inequality. Now that we have understood in detail about the modulus function, let us note down a few inequalities related to modulus. Number 1, if mod of a is less than r, then what we have by this is a is less than r and a is greater than minus of r. So that is the meaning of modulus a less than r. You can also get this condition by simplifying this. If we square both sides, we have a square is less than r square, and if we bring both the terms on one side, we have a square minus r square less than 0, or we can also write this in the form of a minus r into a plus r, and this is less than 0. Now if you are having confusion with this number a, let us take x instead. So let me write instead of a r, because instead of a x, so that you understand it is a variable. So I'm just replacing a as x. So x minus r into x plus r is less than 0. Let us try to plot a number line and mark r here on the number line. If let us say r is positive, 0 will lie here, and hence, so we need to mark 2 points, plus r and minus r. Let us say r is positive, 0 will lie in between minus r and plus r. So let us see what we have when we put the value x equal to 0. we get minus r into plus r, which is negative. So we need to put a negative sign here. Here we need to put a positive sign. Here we need to put a positive sign using the wavy curve method. And from here, you can see that we want this value x minus r into x plus r to be less than 0. And here we have a minus sign in between minus r to plus r. So the solution is x belonging to minus r to plus r. And that is how we get the solution for the property that we have written here. So similarly, if we have an equal to sign here, what we have to just do is put an additional equal to. And second, if modulus of a is greater than r, then we have a is greater than r and a is less than minus r. So that is the answer in case when modulus of r is greater than r. So let us now quickly look into the question that has appeared in JEE 2002. The question was, find those values of x which satisfy the inequality x square minus modulus of x plus 2 plus x is greater than equal to 0. Now here the modulus sign is in an expression which is quadratic in nature. So in this case, how do we approach is as follows. We will take two cases. Case 1, when x plus 2 is greater than or equal to 0, which means x is greater than equal to minus 2. Now in this case, what it does is the modulus sign can simply be removed, and hence we have x square minus of x minus 2 plus x is greater than equal to 0. Clearly we can cancel out minus x and plus x, and hence we have x square minus 2 is greater than equal to 0, which can also be written as x minus root 2 into x plus root 2 greater than equal to 0. So let us now plot the number line and use the wavy curve method. So here we have two values, minus root 2 and plus root 2. Let us see what sign we get when we put the value of x equal to 0. So if we put x equal to 0, we get negative value. So 0 lies in the interval between minus root 2 to plus root 2. So here we have a minus, here we get a plus, and similarly here we have a plus. So this condition is satisfied by all values of x which belong to minus infinity to minus root 2 union root 2 to infinity. Now we have an equal to sign here, so these 2 points are also included, and hence we have a square root at the points minus root 2 and root 2. So this is about when x plus 2 is greater than equal to 0. Let us now discuss case 2, when x plus 2 is less than 0, that is to say x is less than minus 2. Now here what happens is if we remove the minus sign, we get a minus sign here. So the equation becomes, the inequality becomes x square plus x plus 2 plus x is greater than equal to 0. Now this is x square plus 2x plus 2 greater than equal to 0. Now this quadratic expression which we have can be written as x plus 1 whole square plus 1 greater than equal to 0. Now if you look at this inequality carefully, we find that this is a perfect square which is certainly going to be greater than equal to 0, and if we add another constant which has a magnitude 1, then certainly the left hand side is always going to be positive. So this is valid for all values of x. So here x is satisfied for all values satisfying these two conditions. So let us try to put these two cases on a number line and get the final answer. So first let me draw the number line. us mark minus root 2 and plus root 2. Also, we need to mark the point minus 2. Now, minus 2 will be somewhere here because root 2 has a value 1.4. So, minus 2 is going to lie on the left hand side of minus root 2. So, let us now try to understand what the solution will be like. When x is greater than or equal to minus 2, that is, for all values lying on the right side of minus 2, the solution is from here it will lie. So, till minus root 2, it is from minus infinity. So, all these values will be the solution. We have solid circle at minus 2 and minus root 2, and all these values will be the solution. And from root 2 to infinity, definitely all the values of x satisfy the given condition. So we make a solid line, highlight the portion which is on the right side of root 2. Let us now quickly look at case 2. Here for x less than minus 2, all the values of x satisfy the inequality. So from here to here, all the values of x are a solution. So we need to highlight the left hand side of minus 2 as well. Now here, carefully if you look at the number line, we find that x belongs to minus infinity to minus root 2. Root 2 will have closed interval and then union root 2 to infinity. So this is how we solve questions when it is involving modulus sign. Now after this, let me solve another question here using the properties of modulus. We have just now seen two properties. Property 1, when modulus of a is less than r, and the second property, when modulus of a is greater than r. So here the question is, find those values of x for which the following inequality holds. Now here it might look very complicated to you because there is a modulus sign which is inside another modulus sign. So you might have a difficulty trying to understand or approach this particular question. Now we have just now seen two properties related to modulus. So if we apply that property, we can write, we understood that modulus of r, if it is less than or equal to r, we can write minus r is less than or equal to a is less than or equal to r. So using this property, let us expand this inequality, and therefore we can write minus 1 is less than or equal to, the modulus sign goes away, modulus of x minus 1 minus 1, and this is in turn less than or equal to 1. So let us now first consider the left hand side of the inequality, that is this part minus 1 less than or equal to modulus x minus 1 minus 1. So here if we simplify this further, let us add 1 on both sides. So we have 0 is less than or equal to modulus x minus 1, and since modulus of x minus 1 is greater than or equal to 0, let us try to analyze this using the graph. So the modulus of x minus 1 will have a critical point at 1, and the graph would look like V. Here is the point 0, 1. Now this part x minus 1 modulus greater than 0 is definitely true for all values of x. No matter what value of x you take on a number line, you find that the graph of modulus of x minus 1 always lie above the x-axis. Hence, all the values of x satisfy this inequality. So, for the first case, x belongs to r is the answer. Let us now try to satisfy the other inequality, which is modulus of x minus 1 is less than or equal to 1. So if we add 1 on both sides, what we have is modulus x minus 1 is less than or equal to 2, which means again we can write x minus 1 is less than equal to 2 and is greater than equal to minus 2. So from here, if we simplify this further, what we are left with is minus 2 plus 1 is minus 1 is less than equal to x is less than equal to 3. And in this case, we find that only values belonging to closed 1, 3 satisfy this condition. And hence, if we take the intersection of these two solutions, we find that the solution set is x belonging to minus 1, 3.